Okay, this is Algebra 2, Saxon Lesson 2. We're going to talk about negative exponents. We said when you have 2 cubed, it's the same thing as saying 2 times 2 times 2. Yes? Which is simply 8. What if I had negative 2 to the second power? Well, this is an implied negative 1. So this 1 is not protected. There's no parentheses to protect it. So therefore, the negative is not squared, just the 2. Therefore, it's negative 1 times 2 times 2, which simply gives us negative 4, not positive 4. This is a mistake that a lot of people make. Now, what if I change this same power up here to say negative 3? Sorry, negative 3. Well, that negative says you need to do its reciprocal of 2, which is 2 over 1. So this simply becomes 1 over 2 cubed. Now the negative exponent becomes positive. This now gives us our definition of x to the negative n power. It says if m and n, or if n is any real number and x is any real number that is not 0, then x to the negative n is equal to 1 over xn. So basically, this rule, what it tells us that when we write an exponential expression in reciprocal form, the sign of the exponent must be changed. Therefore, if the exponent is negative, it is positive in reciprocal form. If the exponent is positive, it is negative in exponent rules. For example, if you have 1 over 3 to the negative 2, okay, to make that positive, because the exponent is negative, we're going to do its reciprocal. What's the reciprocal of 1/3? 3 over 1. So 3 squared. Now the exponent becomes squared, because this is a reciprocal of that. This is the same thing as saying 1/3 to the negative 2 power, and the reciprocal of that is going to be simply 3, or 3 squared. Yes? Let's do another example. If I did negative 3 to the negative 2 power. Remember that negative 1 is not protected by parentheses. If it's not protected by parentheses, then this negative does not go to this exponent. It's not raised to that power. Therefore, you have negative 1 times 3 to the negative 2 power. So, how do we get rid of that negative exponent? We do its reciprocal. What is 3? 3 is 3 over 1. The reciprocal of that is 1/3. So you have negative 1 times 1 over 3 squared. Because we did the reciprocal, the exponent now becomes positive, and we can simply say negative 1 over 9, or simply negative 1/9. Now, what if I had this? What if I had a negative times a negative 3 to the negative square? How would I do that? Or actually, let's make that to the negative 3rd power. Well, the first thing we see this negative is outside the parentheses, so it's not protected. So I'm going to put the implied negative 1. This one is protected by the parentheses, so it's going to go to that power. Well, the power is negative. We said the rule says to get rid of the negative, we do its reciprocal. So simply you have negative 1 times, the reciprocal of negative 3 is negative 1/3. And now my exponent becomes positive because I did the reciprocal. Now I simply have negative 1 times negative 1/3 times negative 1/3 times negative 1/3. What do we know about negatives? When you multiply and you have an even number, that becomes positive. If you have an odd number, they become negative. I have 4, so I have even. So I have negative times negative times negative times negative. It's positive, or simply 1. And 3 times 3 times 3 is 27. So my answer is simply 1 over 27. So it's important to remember that negative is not protected by parentheses. It does not go to that power. You have to put it in its own little parentheses and keep it protected outside of this base and that power. Okay, what do we mean when we say x squared? Well, when we say x squared, we say x times x. When we say x cubed, we say x times x times x. Now, what if I wanted to multiply x squared times x cubed? I simply have x times x times x times x times x. Well, isn't that the same thing as saying x to the 5th power because we have x 5 times? Yes. So therefore, we get our product theorem for exponents, which says if m and n and x are real numbers and x cannot be 0, then x to the m power times x to the n power is simply x to the m plus n. What does that say? Basically, it says if you have the same base, meaning these two numbers have to be exactly the same, then you just add the exponents. If there's not an exponent there, you x of powers. If there's not a power there, it's an implied 1. So you still would add the exponents to it. For instance, if we have x squared times yx to the negative 5 times y, or to the negative 4, x to the 5th, and x to the 0. And just on a side note, before we do this, anything raised to the 0 power is 1. Anything. Doesn't matter what it is. It's 1. Could be a variable. Could be lots of variables. It's 1. Okay? But saying that, that's for later on, but just so you know. I'm going to use my commutative property. I'm going to rearrange this. So all my bases that have the same are going to be together. Whoops. Okay? These are all the same bases because in my power it says I can multiply them. So I keep the base and I add the exponents. Well, you've got 2 minus 5 plus 0, which is simply x squared. Then you've got y. Don't forget this. That's a power. Even though there's not a number there, it's an implied 1. So you have 1 minus 4, 1 plus negative 4, which is simply y to the negative 3rd. And that's simply your answer. Uh-oh. Did I do something wrong? Y negative 4. Nope, that's right. Okay, so now, what if I did, and I said I have x squared raised to the 3rd power? Well, that simply says it's protected by parentheses. So basically it says I have x squared times x squared times x squared. Right? 3 times. Now, using my product theorem, I know that they're the same basis, so I just add the powers. 2 plus 2 plus 2, which is simply x to the 6th power. Yes? Well, now, because of that, we got a power theorem for exponents. It says if m and n and x are real numbers, then x to the m times to the n power is equal to the x to the m times n. So basically it says if you have a power raised to a power, you simply multiply them. 3 times 2 gives me 6, m times n. Okay? The same thing holds true if you have x squared y to 4 to the 3rd power. It says, or it keeps going on, you multiply this to every number or variable inside. Okay? So this is x to the 2nd power, so it's going to be x. 2 times 3 is 6, y squared, so 2 times 3 is y to the 6th. What about this 4? It's an implied 4 raised to the 1st power. 1 times 3, so now you have 4 to the 3rd power, and you can evaluate that going forward. Okay? Now, what if I had an area of a circle, or a circumference of a circle? Could I find the radius? Or if I had the area, could I find the circumference? Yes, you could. We know the circumference of a circle is pi d, or 2 pi r. And the area equals to r squared pi. So you need these. So they tell us the area of a circle is equal to 12.2 meters squared. Could I find the circumference? Well, yes, I need to know the radius, or the denominator. In my area formula, I've got radius, yes? So I'm going to use this formula for circumference. But I've got to find r. Well, I know my formula says 12.2 is equal to r squared pi. Can I solve for r? Well, I can divide both sides by pi, and I'll get r squared equals 12.2 over pi. However, I need r, not r squared. So how do I get r? I take the square root. What I do to one side, I do to the other side. Therefore, r is equal to the square root of 12.2 over pi. And if you use your calculator, because we use 3.14, or we use the approximation, we didn't do exact, we're going to say r, and we use a symbol, is approximately 1.97. So now can I find the circumference? Yes, I can. I can find the circumference. I've got r, that's all I need. 2 times 3.14 times 1.97. You multiply that out and you get the circumference is 12.38 meters. As simple as that. That's all that is. Okay, that is lesson 2. We will stop for now. Thank you.